All right, the clock is officially ticking. On July 28, 2026, the Model Context Protocol, or MCP, undergoes its most massive evolution yet. And with it comes a strict 12-month deprecation window for all legacy versions. Welcome to this explainer. Today we're breaking down a monumental shift in how AI agents connect to business tools, and exactly what it means for your enterprise architecture and your security posture. Now, right out of the gate, full disclosure, this summary was actually created using Notebook LM. But, and this is important, absolutely everything we're about to cover is grounded entirely in actual public source material. We're looking directly at the official MCP specification release candidate and the latest threat research from Akamai Technologies to bring you the unfiltered facts. So here's our roadmap for this explainer. We're going to hit the MCP Enterprise Overhaul, check out the eliminated protocol security risks, dive into the new stateless challenges, look at attack vectors and apps, and finally wrap up with securing the new architecture.
Okay, let's just jump right in. Section 1, the MCP Enterprise Overhaul, and that huge shift to going cloud native.
The scale of this architectural change is honestly staggering. Originally, MCP was this local, single-user tool requiring what we call stateful connections. Basically, the server had to perfectly remember who you were at all times. It's kind of like a waiter having to memorize your entire life story just to serve you dinner. But this new July 2026 spec, it rips all of that out. The protocol is now entirely stateless. So that old handshake, gone. Session IDs, gone. Instead, your context travels in a brand new meta object on every single request. This is a massive leap to true cloud-native performance. Your remote MCP servers can now sit behind plain, round-robin load balancers without needing any deep packet inspection at the gateway. It's faster, it's highly scalable, and it completely changes the game for how traffic is routed.
Moving right along to Section 2, eliminated protocol security risks. And honestly, this is the good news part of our analysis.
Because the core architecture got this modernization, several of those legacy security nightmares, they're just gone. First off, by axing that long-lived MCP session ID header, the risk of protocol-level session hijacking is effectively zero. There's literally no permanent session left for an attacker to steal. Second, the days of unsolicited server-initiated prompts are completely over. Compromised servers can't just silently interrupt users with malicious interactions anymore. The new rules strictly block this. A server can only issue an elicitation prompt if it's actively processing a client request. And third, the protocol now mandates strict OAuth 2.1 requirements. And yes, that includes PKCE. So legacy passwords and those old implicit grants are out. The main takeaway? The blast radius at the protocol layer has shrunk dramatically.
But of course, there's always a flip side. Welcome to Section 3, the new stateless challenges, or what we might call the unintended consequences. So here is the crucial catch. Yes, the protocol itself is safer, but that security burden didn't just magically vanish. It got dumped directly onto developers. Think about it for a second. Because the protocol is now stateless, AI agents have to rely on tracking IDs that get handed back and forth between the client and the server. Well, what happens if a developer builds an MCP server that uses predictable IDs, or maybe forgets to cryptographically verify them? An attacker can absolutely manipulate those values to hijack an active workflow, or even access another agent's data. And you know that shiny new meta object we just talked about? If a server just blindly trusts it for routing or authorization, hackers can easily inject malicious key-value pairs and instantly escalate their privileges. It's a huge shift in responsibility.
And this complexity spills right over into networking threats. The new spec introduces specific HTTP headers like MQP method and MQP name to help proxies route traffic. But this opens the door to protocol confusion, or what we call desync attacks. It's literally like handing a bouncer a fake ID at the front door of a club while your friend sneaks in through the back. If a hacker intentionally sends conflicting values between those HTTP headers and the actual JSON RPC request body, they can throw the entire backend infrastructure completely out of sync. This tricks monitoring tools and can completely bypass security gateways.
Building on that header issue, Akamai's threat research highlights another massive risk: data leakage via the XMCP header directive. This is a feature that lets developers map specific tool arguments directly into HTTP headers, which is great for faster proxy routing. But just imagine the nightmare scenario if a developer accidentally maps an API key, an access token, or even personal data into that header. Suddenly, your most highly sensitive secrets are pushed right out into the open. We're talking completely visible to every single load balancer, proxy, and logging system across your entire network path. No way you want that.
Let's pivot over to Section 4, Attack Vectors in Apps, specifically looking at UIs and tasks.
Now, the newly formalized MCP apps extension is incredible for user experience. It actually allows servers to ship interactive HTML interfaces that render right inside AI applications, like Claude Desktop. But bringing rich web UIs into the AI ecosystem means bringing traditional web browser risks right to your desktop. Yep, we're talking about stored cross-site scripting. Now sure, the spec requires hosts to render these interfaces in a sandboxed iframe, but the user is still right there in the crosshairs. An attacker can store a malicious script via an MCP tool, and the very second you view that panel inside your trusted AI, boom, the script runs. They can display deceptive content, launch phishing campaigns with fake login prompts, or even steal whatever data happens to be visible on your screen. Then we've got the new Tasks extension, which is built for long-running, asynchronous work. The thing is, task creation is incredibly cheap for the client, but highly resource-intensive for the server. Akamai warns about what they call hit-and-run denial-of-service attacks. It's essentially like ordering a massive, ridiculously complicated feast at a restaurant and then running out the front door before the bill even arrives. An attacker can send a single, tiny request to spawn a massive database operation and then instantly disconnect. Because the whole thing is asynchronous, the server is just left grinding away through that heavy workload, which can exhaust your infrastructure in a matter of minutes.
Okay, bringing us to our final stretch. Section 5, Securing the New Architecture, your actual defense playbook.
The threat analysis we just went through is pretty sobering, but the defense playbook is clear. Here's exactly what organizations need to be doing during this 12-month deprecation window. If you take literally nothing else away from this explainer, remember this one golden rule. In a stateless protocol, you have got to treat all client-provided state data as entirely untrusted, period. Developers absolutely must enforce strict cryptographic verification for any state objects passed back and forth. That's how you prevent workflow hijacking. To stop those stored XSS attacks, rigorous output encoding is mandatory for all AI-generated visual panels. And for those hit-and-run DOS attacks, you absolutely have to set robust resource quotas and strict timeouts for all asynchronous tasks. The protocol isn't going to hold your hand anymore. We have to build these trust boundaries ourselves. As you prepare your development and security teams for this massive shift over the next year, you are definitely going to want to stay ahead of the curve. So, for more deep dives into cloud, security, and AI insights exactly like this one, make sure to subscribe to the YouTube channel at Elstrin.
Well, we have covered a ton of ground today, from the amazing scalability of a stateless core right down to the heavy new responsibilities placed on developers. The MCP 2026-07-28 update is without a doubt a massive leap forward for enterprise AI, but it fundamentally reshapes where security resides. I want to leave you with this final question to ponder. As the protocol offloads the security burden, are your developers truly ready to defend the new enterprise AI trust boundaries? Thanks so much for tuning into this explainer, and good luck with the transition.